Hey guys, today we're going to be taking a look at these Peltier units and specifically whether or not you can make ice with these things. And when I say make ice, I mean an actual reasonable quantity of ice, like an ice puck or something like that. Because sure, you can put a couple drops of water on here, it'll make ice. But I kind of have my doubts that it'll make any reasonable amount of ice. But anyway, I'll go ahead and bring this one in here because this has already got a heat sink on it. And just in case you're curious why I have such a weird looking heat sink, that actually got pulled out of an Xbox 360, I believe it was. So anyhow, that's what that's from. I got to mount a couple of fans on there, and I'll go ahead and get that done, and we'll hook this up and see if we can make ice with it. Alright, so I've got it set up all wired up here. I've got a fan stuck underneath this heatsink. It's all sitting on top of the Helping Hands unit here. I'm going to power it off of my lithium ion battery pack here, so we'll go ahead and kick that on. And first off, we'll just see how cold this will get. I'll put a couple of drops of water on there. We'll see what it does. I got a reasonably powerful fan stuck on there, so let's see what we get. That's Fahrenheit degrees, 10 or 12. Actually, you're all the way down to almost 0 there. At 2 degrees, 1.2 degrees, the coldest spot. It's not bad at all. Celsius is about negative 16, highest I saw there. Negative 16.7. So it should be plenty more than enough. Actually, it looks like it's already starting to get ice crystals on it just from the humidity in the air condensing down on there. But we should definitely be able to melt, or sorry, freeze water. I'm not sure how long it'll take. Still water. And this is kind of why I'm having my doubts on whether or not this will actually freeze any reasonable amount of ice. Just because of how long it takes to freeze that little bit of water. But it is freezing it. And these are just cheap little Peltier modules. I think they were like 5 for $10 or something like that. They weren't too expensive at all. Battery voltage is at about 11.89. Wasn't fully charged to start with, so we'll see where we go here. And we're still not completely frozen, though this part up here is. Okay, yeah, that's pretty good. That's almost completely frozen. If I turn this off, you'll see that starting to kind of float in there. And you could actually, when I turn that off, you could see the ice crystals on it from the air actually melting and going across that. So anyway, there we go. Now if I spread this out, it should actually freeze pretty quickly. The heat sink's a little bit warm, but I think that fan's gonna do just fine. Yep, that's, oh no, it's not ice yet. It'll take a second to move the heat from one side to the other. There we go, that's ice. Mostly ice. Alright, so I gotta go get something that I can freeze water in, hopefully without breaking it. Alright, so I'm going to use the water itself as kind of a thermal paste, so to speak. So we're just going to put a bit more on that. And I've got 50 milliliters in this glass beaker, which is going to break if it actually does freeze. Or it's probably going to break anyway if it actually does freeze. We'll see if it actually does or not. Supposedly really strong glass, but we'll see. I'm more interested to see how low of a temperature we can get with this water than I am if it actually freezes or not, because I'm pretty sure it's not going to. But anyway, The reason why I don't want to use a metal cup is A, I don't have one that actually has a flat bottom on it. I actually don't have a metal cup at all. I don't really have anything but this that has a good flat bottom. But the other thing is that metal cup will actually act like a heat sink, or I guess it'd be more like a cold sink. Now, technically, glass is an insulator, so it's not going to pass that temperature through it very easily. But we're going to see what happens. We're going to turn this on. And I suppose we'll have to leave it on for a while and see what it actually does, but anyway, I don't know if I can get a reading with this thermometer or not. I kind of doubt it. 23 degrees, 73. Anyway, it's going to take a while to cool that off, so I'm just going to leave it here. I'll make sure it doesn't overheat, and hopefully this water will actually start to freeze. Alright, so one more thing I'm going to do here before I leave this video, or let this thing sit. I went ahead and stuck a little thermocouple in there. This is kind of a weird one because it's got this long piece of metal on it. But this is actually meant for liquid and air temperature readings, not surface spot checks. But if I put my fingers here at the very end, the temperature actually does raise up pretty quickly. So I'm assuming that the actual thermocouple inside of this is right at the end. And we should actually be able to measure the temperature of that water reasonably accurately. Right now we're at about 65 degrees, looks like, and hopefully dropping. That started out at about 73, or it should have started out at about 73. Anyway, it should have been about room temperature water. But anyway, it is cooling off. We'll see if it actually makes ice though. Alright, so this is where I'm going to call the test off because it's been on here for, I don't know, an hour or so. But the temperature has pretty much stabilized. It's bouncing between about 44 and 45. Sometimes you see 43 on there, but anyway, it's not particularly dropping at all in temperature. So anyway, that's not much of a surprise to me. I didn't think it was going to freeze, but honestly, I didn't think I'd be able to get it that cold either. 44 is actually pretty reasonable. It's a little warmer than what a normal refrigerator would be, I would say. It feels like the water that I put between the Peltier unit and this thing is actually frozen onto the glass, but if I stick my finger down in here, it is definitely cold. There we go. Take that off now. And now it's going to be on ice, so it's going to be real slick, but it's definitely colder than when we started. Actually, look at that. There actually is ice in the bottom of that. This may actually still be, maybe I do need to leave it on here longer than that, because that's actually ice down there. It just melted. There's a chunk of ice in the bottom. A reasonable chunk of ice. You can see that. So I might just have to leave this on here longer, even though the temperature of the water's not really changing. Shut that off so this can come back to a liquid. So actually I will leave that on there a little longer and see what we can get. So that's kind of interesting. It's melting pretty quick. But like I said, it's been on here for quite a while already, so yeah, that's where all the water's going off the side. That's okay, it's actually landing right onto a sponge. That's funny. Anyway, stick that back on there, maybe. If I can get it on there in a decent position that's not covered in ice, which none of that is. Yeah, well, that's good enough. I'll go ahead and let this keep going then, if it actually does have ice in it. So, I'll put this back in here. So we may actually have some ice, or an ice maker here. Let's check the voltage of the battery pack here. Unfortunately, my the battery in my meter here is starting to die, and I don't have a new one. Got a little battery light there, so readings may not be completely accurate. Actually, I may not have any power left in the meter. There we go. Battery voltage on this lithium ion pack is down to about 11.5. So I might have to switch over to a power supply in order to power this thing eventually, but for now, it is still working. So Let me go ahead and leave this here, and I'll leave it there for like an hour or so, and we'll just see what it does. Alright, so I'm going to go ahead and call this test here because my battery's starting to get kind of low. But there is ice in there. I'll show you here. I had ice in between. Actually, there's a chunk of ice right on this thing where I had that water in there as a thermal compound. There's ice on the Peltier unit itself there. I'm not even entirely sure how long this has been running at this point. I just know it's been quite a while. I'll have to go back and look at the files and see. But anyway, let's see how much ice we actually have in this beaker. So that down there is a solid chunk of ice. So that's it's a reasonable amount of ice, I suppose, but considering how long this has been on, it's not really that reasonable. It's been on. Technically, I never had this thing up above 12 volts. So if you're in like a car or something using a higher voltage power supply, like 14 volts or so, it might go a little quicker. But anyway, there is a decent little bit of ice on that. It's not a whole lot. It's probably about 1 or 2 ice cubes worth, I'm not sure. But it did make ice. It used a lot of electricity to make that ice, but it did indeed make a little bit of ice. So anyway, hopefully you enjoyed that little bit of an experiment with a Peltier unit. Maybe you learned something, but anyway, that's it for now, guys. Bye.